In this video, I will quickly go over how Grasshopper and processing interface and how you can actually get the entire system to work. So first of all, make sure you went through all the prerequisites and installed all the necessary plugins and features and libraries and softwares. Otherwise, this unfortunately will not work if you don't have one of these installed. Once you download the entire project, you will have this folder here. And for once, we will open robot handwriting, the Grasshopper definition in Grasshopper, and we will also open the touch drawing to JSON and GH processing file in processing 3. Let me show you how it works. Once we open the processing file, we will hit run, and we are presented with this screen. And on this screen, we can actually start drawing and write whatever we want on there. And we also have the option to do something new, to reset the canvas, and to draw something different. Let's draw some just random shape here, some smiley. Okay, and once we hit go, this will actually send all of the lines we just drew into Grasshopper. But for this, of course, it's necessary that Grasshopper is running and that the definition is running. So let's hit go, and we will go out of this window by hitting Alt and F4. And you can actually see the sketch is loaded into the Grasshopper definition. And if we select it here, we can also see it flat here and also in actual position. So how did this work? Well, first of all, in the processing sketch, it should be noted that you would probably want to have a second monitor with a touch input, and this is where you would want to display the actual sketch interface and what you just saw, the actual interface where you can write something. And to get the processing sketch on a different monitor, you simply go to File, Preferences, and then Run Sketches on Display. You simply select a second display, which hopefully has a touch input or something similar, where you can then have people draw on. So you saw that once we hit go, the sketch immediately got into Grasshopper, and there it is available to actually be drawn by the robot. We have a robot simulation component here, and which we can click. And if we select sketch in position and the actual simulation, we can also see how the robot will actually move through the entire sketch and actually sketch it out exactly in the same order as we drew the lines in processing. So the actual communication between processing and Grasshopper is done via the UDP protocol, and this is the plugin called GHOWL, or rather GHOWL, which takes the processing script, which communicates with a processing script. This happens on this line here. Please forgive the messy code, but you can see here it sends udps.send, and then it sends the message. This message contains the actual lines, and then it also sends a message which is just a boolean, which is set true, and then afterwards it's set false. And this boolean actually makes it so the sketch is immediately executed by the robot. So you can see this boolean, which is actually sent to a different port in Grasshopper, is then sent directly to the robot and activates the upload function on the remote connection. In this case, I deactivated it because if it's activated and you don't have a robot connected, this will give Grasshopper a bit of a headache and make it slow to connect. So make sure that if you open definition and you don't have a robot connected, you simply disable this component, and if you do have a robot connected, of course you have to enable it again. So the thing that is actually received in Grasshopper is a text file, or rather a lines of text in a JSON format, and Grasshopper then uses the GHJSON plugin to parse this text and make it so from these lines of text we actually get points we can use, and you see this here. This is what is received, and then after a while, after some processing is done to it, you actually get points which can then be used to really create the geometry we need, which is done right here. Afterwards, most of the components are just list management and some geometry functions which create a writing surface. This is actually the surface where the sketch will be put on, and then it actually orients the sketch and puts it into this writing surface. So to define this writing surface, you actually use this configuration area here, where you will simply input the coordinates of 3 points of your writing surface. This is the top left, top right, and bottom right points, as you can see here, and these points define the writing area rectangle. This is important that you get this right, that you get this from the robot by simply moving the robot to where your writing area starts, and then noticing, like writing down the coordinates there, and make sure that your TCP is also correct. And yeah, without going too much into details how this definition actually works, let's just look at a few functions, a few things that are still on here, especially in this part of the definition, because optimally you should not need to go into any of the later parts of the Grasshopper definition, but you can do everything that you need to do in the frontier. So this is the program code and errors. So if you might have some warnings here, depending on how your robot is set up and how big your writing area is, but this usually shouldn't be a problem. But if something is out of reach, if something is too far away, you will get an error, and it will tell you, hey, this is out of reach, and the robot will actually not execute your program. This group here is a simulation of the robot, which is quite handy because it will actually simulate how the robot will move through the entire sketch that you did, and you can also verify here that everything is going smoothly. However, usually you would immediately execute the drawing once somebody hits go on the processing sketch, so you will not validate every time something is sent to the robot. Here you have some secondary commands. You have another switch that can toggle the upload to the robot, and you can also play and pause the robot from here. Very important, this is the robot IP address. Make sure that this matches the IP address of your robot, and make sure that it actually is correct. Otherwise, of course, Grasshopper cannot communicate with your robot. And here you will have the geometry, which is handy to verify. Okay, this is the geometry, how it gets into Grasshopper from processing. This is it in position. This is the writing surface, and you will also have the actual planes of that the robot will move to, and this is a simulation of how the robot will move, and it will also show how the robot will move upwards. This can be configured in this area down here. You can see if I set the move height higher, the robot will move in Z direction a bit higher after each line. This also generates, or not generates, but defines how precise the robot, or rather Grasshopper, will handle the sketch you give it. So if you look carefully down here, you will see that if this number is higher, there will be less points, and so the whole drawing will be a bit rougher, and there will be more straight lines, and it will not look like a very smooth drawing, but it will make the entire thing a bit quicker, and also the drawing a bit quicker. You can also set the robot speed here, and the radius of the zone of the robot, which means the radius with which it connects two lines, so it won't make a hard corner, but instead will hopefully do a soft radius there. And yeah, that's basically it. That is how the entire thing works. If there are any issues with the program, don't hesitate to create an issue or to contact me. You will have options to contact me on GitHub by raising an issue, or through my email, which you will see in the description here. Thank you very much.